Yes, all the students. Now we are going to target the unit electrical installations. So it is common for CSE as well as civil. So for CSE it will be unit 5 and civil it will be unit 2. So the topics will be common here. So components of low tension. Here LT stands for low tension switch gear. So what is the switch gear here? So the combination of all the switches, right, such as switch fuse unit, MCB, ELCB, MCCB, which are used to protect the electrical circuits, is called the switch gear. And if the voltage level is less than 1 kilovolt, then it is called low tension or low voltage switch gear. Okay, right. The combination of all the switches such as switch fuse unit, MCB, ELCB, MCCB, which are used to protect the electrical circuits, is called switchgear. If the voltage value is less than 1 kilovolt, then the switchgear system is called the low tension or low voltage switchgear. So for us, first we concentrate on MCB and ELCB. So the construction of MCCB is similar to the MCB only. Only the thing is, if at all the very large value of current, let us say 300 amperes of current, for very large values of current, we go for the MCCB. That is the only difference. So MCCB is used for very large values of the current in the place of the MCB. So ELCB is also called as RCB, residual circuit breaker, and earth leakage circuit breaker. Both are same. Miniature circuit breaker is MCB. Okay, modeled case circuit breaker. So what is the simple difference between a switch and the circuit breaker? So ordinary switches, whenever short circuit condition occurs or whenever large current flows through our house, these switches might be operating under fault condition. Circuit breakers, they trip off the circuit. That means they protect the circuit whenever large currents or short circuit currents start to flow. So circuit breakers is what the future switches, we can say, if at all you are handling with heavy currents. Okay, right. So what exactly this unit? This unit is all about theory. Don't miss this particular unit. We take each topic here. Right. So let me share this slide. First, to target MCB, we are going to take. Right. So if you see the electrical installation, so electrical installation, switch gear, both the definitions are same. Electrical installation or switch gear, the combination and assembly of different switches, MCB, MCCB, ELCB, which are arranged in an order to protect the circuit, is called the switch gear system. You can see different switches we got. Now, so before we discuss any topic, let me show you one mechanical device. This is called the latch. A latch is a mechanical object which is free to open and close. That means it has got one fixed contact and movable contact. Okay, so always movable contacts opens and close. Right. So this latch can be connected to any other device. So now our topic is MCB, miniature, that is very small, miniature circuit breaker. So in simple terms, the ordinary on-off switches which we use in our day-to-day life, they cannot protect us from the large currents which flow due to an abnormal conditions or any due to short circuit condition. So this is the internal structure of one MCB. Okay, so let us see the first thing. Yes, MCB, this is the outer part you can have. So this is what the structure of the MCB. Now we have to explain. We got certain diagram, same diagram we cannot draw. So what is the operation of the MCB? MCB works for two conditions. So it protects the circuit. That means the MCB should be always connected between your circuit and the supply. Circuit means in general terms in our house where we have to place the MCB. MCB should be placed between the load elements, that means fridge, washing machine, TV, all these components can be connected to an MCB, and MCB is connected to the supply, power supply. So whenever any fault condition is arising, this MCB turns on and it disconnects the load, all the elements. In technical language, MCB turns on and trips off, okay, right, trip off we can use. Now we are going to discuss this one, the miniature circuit breaker. So what exactly present inside this one? Yes, we got different elements. So MCB explanation in MCB operation can be given for short circuit current flow and for overload currents. So overload current and short circuit current, what is the basic difference? See, outside you are having poles. Near the poles you got the wires, okay? If at all any two wires are in contact, we say that is called the short circuit condition. And overload current. So in our house, at a time, if you are turning on all the electrical components, that to iron box, boring machine, okay, and heavy loads, if all the heavy loads, example geyser, induction stove, if all the heavy loads in an house are turned on at same instant of time, then current flowing through the house is called the overload current. If any two wires are in contact by fault condition, that current flowing through the circuit is called the short circuit current. MCB protects the components from short circuit current as well as the overload current. So how it will protect from short circuit and overload? First we discuss for the overload current. Okay, MCB protects the components from short circuit and overload currents. First explanation will be for the overload currents. MCB practically contains, yes, MCB practically contains, let me show. MCB, if you see, MCB practically contains inlet, this is incoming inlet, and outlet, followed by bimetallic strip. You can see this is the bimetallic strip, and magnetic coil, you can see here. So four major parts, right? The MCB contains inlet, outlet, bimetallic strip, and magnetic coil or electromagnetic coil. So let us check with another animation what exactly the structure MCB has got. It is a lever or the mobile contact, okay. Inlet, as I mentioned, MCB contains inlet, electromagnetic coil, bimetallic strip, and outlet. All these are connected in series, four components. Same current flows through all the four components. You can see same current is flowing through the inlet, electromagnetic coil, bimetallic strip, and the outlet. Let us check that. Now, this is what the, as I mentioned, the bimetallic strip first. Now, this is called the latch. Just now I have shown you. One is fixed contact and this is the mobile contact. So what is this? How it operates? Imagine first you must observe this particular knob. Initially, it will be under on condition and then it turns off automatically. Whenever overload current or short circuit current flows, this particular knob or latch, it turns off automatically. Okay. Now you can see it is at the positioning the top. Okay. Whenever fault current flows, it comes down. So let us take the explanation for the overload current first. You can see here. So for your understanding, I'm showing on, it was up and it is turning down automatically. Automatically it protects the elements. So first we go with the explanation for overload currents. Right. So what is the working principle? So whenever overload current flows through the circuit, that overload current flows through the MCB. Whenever overload currents flow through a circuit, that overload current first flows through the MCB. Whenever overload currents flows through a circuit, those overload currents flows through the MCB. These overload currents initially flows through the bimetallic strip present inside the MCB. Bimetallic strip, due to the flow of the overload currents, changes its position, it expands, and it obtains a new position in the form of a bend shape, just like a curve shape. So this change in the position of bimetallic strip is applied on the latch. You can see this position, latch. So latch, just now I've shown you the animation. It is a mechanical element which opens and closes. Latch is physically connected to the switch, lever or switch. So with the change in the position of the latch, the switch also automatically turns off. So whenever overload current flows through the circuit, that overload current initially flows through the MCB. That is, it flows through the bimetallic strip. As a result, bimetallic strip gets heated up, expands and changes its position into a bend structure. The change in the position of the bimetallic strip is applied to the latch. Proportional to the change in the position of bimetallic strip, the latch also changes its position and finally changes the position of the lever. In this way, the lever or the knob, which was initially under on position, it turns off. This is the first explanation. You can see now the current is flowing through the bimetallic strip. Okay. Latch changing its position, and finally latch operates. You can now concentrate on this knob. Yes, it changes its position. This is the first explanation in short. Whenever short circuit currents flow through the circuit, those short circuit currents first initially flow through the MCB, because MCB is placed between the supply and the electrical components. Whenever short circuit current flow through the circuit, those short circuit currents initially flow through the MCB. That is, short circuit currents flow through the electromagnetic coil of MCB. Whenever current flows through the electromagnetic coil, huge strong magnetic field is created across the electromagnetic coil. This strong electromagnetic field attracts the plunger. You can see this is the latch and this particular point is called the plunger here. Plunger. Okay. I will show here also. You can see this particular portion is called the plunger or the movable switch. Initial movable switch. So whenever short circuit current flows through the MCB, that short circuit current flows through the electromagnetic coil. Now you can see, so whenever current flows through the electromagnetic coil, strong magnetic field is created. That magnetic field attracts the plunger, which is made up of the iron. So this plunger is connected to the latch. Change in the position of the plunger, Plunger. Change in the position of the plunger changes the position of the lever. In this way, the MCB changes its position from on to off. You can see here. Now magnetic coil is created. The plunger was in different position. Yes, current flows. Now plunger was, yes, changing its position. On and off. This is a simple operation of the MCB. Okay, right. So now we move to the next concept. You can see the MCB diagram. What you have to draw in the examination is this particular diagram. So this is for the bimetallic strip. Okay, common diagram. So MCB practically contains, you can see electromagnetic coil, bimetallic strip. Okay, latch. This is the latch. Movable contact. You can see open contact and closed contact, fixed contact, movable contact, fixed contact. So under normal operation, safe, whenever small current or safe current is flowing, MCB operation is 0. So whenever overload currents or short circuit currents flow, imagine here, whenever overload current flows, the bimetallic strip gets heated up, and changes its position into a curvature or the bend structure, and this bend position is applied on the latch. Now the latch, which has got the fixed contact as well as movable contact, the movable contact changes its position. It moves away from the fixed contact. In this way, the MCB gets off and thereby protecting the circuit. Okay. This is a diagram you have to draw. This is the electromagnetic coil, the same explanation. Now, next we go for the earth leakage circuit breaker. So what is the main advantage? If at all, what is specialty of this Elcb? So whenever short circuit currents are flowing through the house, if any person is touching the switchboard, they might get the shock. But if you are using Elcb type of switch, you will never get the shock. Entire supply will get turned off. So how it happens, we'll see. So first we must study the simple definition of the relay in order to study Elcb. A relay, R-E-L-A-Y, a relay is an electrical switch which connects and disconnects the circuit. If you see, I want to connect the bulb. So what I have to do, first close the switch. Okay, this is the relay circuit. So first, a relay is an electromagnetic switch which connects and disconnects the circuit. First close the switch here. Current flows through the coil. Magnetic field is created. That magnetic field attracts the iron. Here this is made up of the iron actually. Attracts the iron. Therefore the switch 3 gets closed. When switch 3 gets closed, current flows through the circuit and the bulb is on. So relay connects and disconnects the circuit in simple terms. So we are not supposed to write anywhere the definition of relay. They will not ask you separately, but I am showing separately what exactly the relay is. So what is this Elcb? Okay. First you see RCD or Elcb, both are similar. Earth leakage circuit breaker practically contains a simple transformer, 2 wires, the phase and the neutral. Okay, phase and the neutral. No need to mention this fuse or MCB. No. Elcb practically contains transformer, a phase wire and the neutral wire. The wire which carries the current is called phase wire, and the wire which carries the zero current is called the neutral wire. Now, on this phase and neutral wire, we are placing a circular iron ring or toroid, T-O-R-R-O-I-D. So toroid coil or circular iron ring is used in Elcb. Phase wire is wounded or placed on the circular iron ring at one end. Similarly, neutral wire is also wounded or placed on the circular iron ring. When the supply is on, current flows through the phase wire, which is called I1. Current also flows through the neutral wire, which is called I2. I1 and I2 currents create 2 magnetic fields, Phi1 and Phi2. The strength of the 2 magnetic fields are equal to each other, but they act in opposite direction. Therefore, the total magnetic field equal to 0 under normal condition. So what is the explanation? Elcb practically contains 2 wires, phase wire and neutral wire. Phase wire is wounded. Elcb also contains a circular iron ring on which phase wire is wounded at one end and neutral wire is also wounded at another end. So the current flowing through the phase wire is I1, the current flowing through the neutral wire is I2. These 2 currents I1 and I2 create 2 magnetic fields, Phi1 and Phi2. These 2 magnetic fields act in the opposite direction with same energy and same intensity. Therefore, under normal operation, both magnetic field cancel out each other. Therefore, the total current equal to 0, total energy equal to 0. Now, under fault condition, let us say under short circuit condition, what's going to happen? Under short circuit condition, whenever short circuit current flow through the circuit, the current I1 is not equal to I2. Here you can see both the magnetic fields are created. Under short circuit condition, the value of the current I1 is not equal to current I2. Therefore, the magnetic fields phi1 value is not equal to phi2. Under this condition, due to the difference of both the magnetic fields, a new magnetic field will be created, which is called phi3. You can see now pink color winding which is shown here. It is saying that new magnetic field is created. Now that new magnetic field will link with the winding 3. That is the new winding or the new inductor. So whenever a magnetic field links or interacts with the winding, current starts to flow through the coil. Current starts to flow through the coil. Now this is the relay which I mentioned. Initially the relay will be closed, but whenever short circuit condition is created, relay turns off, trips off the circuit, or it opens the circuit. So how it is possible? Under short circuit condition, whenever the current flows through the wires, I1 value is not equal to I2, magnetic field phi1 is not equal to phi2. As a result, due to the difference of these two magnetic fields, a new magnetic field is created. That magnetic field links with the third winding. As a result, current flows through this winding and relay turns on. When relay is turned on, it turns off the circuit, thereby protecting the entire circuit. You can see the animation now. The relay trips off the circuit. Initially it is closed. Yes, you can see it is turning off. So in this way we protect the different circuits. Examination, you can draw this circuit. Okay. The supply, the relay, 3 windings and the load.